Hi students, good morning. I hope you all are fine. Welcome to grade 11 business mathematics class. We are learning our second chapter algebra. In that we are learning last before section, that is mathematical induction. I started this section in the last class and I taught 3 problems and I gave one homework for you. I hope you all completed. I said it's a very important section, so concentrate and learn well. Okay, so let's move to the today's class. We will start from example 2.37. Okay, example 2.37. Question is, show by the principle of mathematical induction that 2 power 3n minus 1 is a divisible by 7 for all n belongs to n. Okay, listen the question carefully. Show that by the principle of mathematical induction we need to prove 2 power 3n minus 1 is divisible by 7. We need to prove it's divisible by 7 for all n belongs to n. Okay, solution. So first what will you do? We will define as P of n. Okay, let's the given statement P of n be defined as P of n is equal to 2 power 3n minus 1. Okay, given statement. So this is common for everything. Okay, so step 1. Step 1, what will you do? Put n equal to 1. Is it right? So put n equal to 1. Okay, what is value? P of 1 is equal to 2 power, here it is no LHS and RHS, that is we need to prove 2 power 3n minus 1 is divisible by 7. Okay, so 2 power 3 into 1 minus 1. So 2 power 3 means 8 minus 1 is equal to 7. Whether 7 is divisible by 7? Yes, correct. So 7 is divisible by 7. Therefore, what we will say? P of 1 is true. Understand? So first you need to assume the given statement as P of n. Then their previous problems are LHS, RHS we will prove. But here 2 power 3n minus 1 is divisible by 7 you need to prove. For that, if we substitute n equal to 1, we get the value as 7. So whether 7 is divisible by 7? Yes. So P of 1, when you are substituting in the place of n as 1, we got the number that is divisible by 7. So we will say P of 1 is true. Okay. Step 2. Let's assume that the statement is true for n equal to k. Okay, so if we substitute n equal to k means what will happen? Shall we assume? That is, we assume 2 power in the place of n, what you need to substitute? K minus 1 is divisible by 7. Okay, the meaning is 2 power 3k minus 1 is equal to 7 into m. That is, the thing is 7 into any number. If you are getting 7 into 1, m as 1 means that also divisible by 7. 7 into 2 means 14, is it right? So that also divisible by 7. 7 into 3 means that also divisible by 7. So 7 into whatever the number may be, that number must be divisible by 7. Understand? So if we assume 2 power 3k minus 1 is divisible by 7 means the meaning is 2 power 3k minus 1 value must be always equal to 7 into something. Okay, 7 into 1 or 7 into 2 or 3 or 5 or something. Okay, so if you need to find out this divisible by 5 means how will you write? 5 into m. Okay, so 5 into 1, 5 into 2, whatever may be, it will be divisible by 5. Understand? Okay, now we will move to the last step, step 3. Step 3. What you need to prove in step 3? To prove P of k plus 1 is true. We need to prove P of k plus 1 is true. Okay. Now, in the place of k, what you need to substitute? K plus 1. Okay. So, P of k plus 1 is equal to 2 power. In the place of k as k plus 1. Is it right? So, k plus 1 minus 1. That is equal to 2 power, multiply inside 3k plus 3 minus 1. Now that is equal to, shall we split as 2? That is 2 power 3k into 2 power 3 minus 1. That's equal to 2 power 3k into 2 power 3. What's the value? 8. 8 minus 1. Okay. That's equal to, shall we write this 8 as 7 plus 1? You will have it. Why you are writing this 8 as 7 plus 1? We need to prove that a particular number is divisible by 7. So I am splitting 8 as 7 plus 1 minus 1. That is equal to 2 power 3k into 7 plus, multiply inside. Okay, this is into. So 2 power 3k into 7 plus 2 power 3k into 1, is it right? So 2 power 3k into 1 is 2 power 3k minus 1. Okay, then that's equal to 2 power 3k into 7. This together, how will you write? As plus 7m. You will have it out. From where you wrote that 7m, is it right? If you need, you take this as equation number 1. So it will be very easy for you. Okay, so using 1. So 7m. Okay. Now what is common? 7 is common. So 2 power 3k plus m. So 7 into something. Now you see whether it is divisible by 7 or not. Yes or no? Yes. I will repeat here. So in the place of k, substitute k plus 1. Multiply inside. Split as 2 power 3k into 2 power 3 minus 1. 2 power 3k into 2 power 3 means 8. 8 minus 1. 2 power 3k into 8, I split as 7 plus 1. The reason is I need to say whether it's the particular is divisible by 7. So 7 plus 1 minus 1. So 2 power 3k into 7 plus 2 power 3k into 1 is 2 power 3k minus 1. So 7, this together by using 1 I will write as 7m, 7 into something. So from here I took 7 outside. So which is divisible by 7. So 7 into something means is divisible by, the meaning is which is divisible by 7. Got it? So if you need to prove whether it is divisible by 5 means 5 into something you will get. So 24 means 24 into something you will get. That's the meaning. So therefore we will conclude the answer P of k plus 1 is true whenever P of k is true. Whenever P of k is true means P of k plus 1 is also true. Therefore P of n is true for all n belongs to n. Therefore it is good. Got it? So very easy as well as very important question. Okay, let's move to the next problem. Next question. Example 2.38. By principle of mathematical induction, prove that n square plus n is an even number for all n belongs to n. Okay, so by the principle of mathematical induction, we need to prove n square plus n is an even number. So what are the even numbers? All of you know whether it's what's the even number, what's the odd number? Yes. Okay, in your class you learned, is it right? What is even number? What's the prime number? What's the odd number? Is it right? So same thing. So even number, we need to prove n square plus n is an even number for all n belongs to n. So same thing. Solution. First you will take let P of n be the statement. That is, let P of n denotes the statement that n square plus n is an even number. That's the given statement. Okay. So for step 1, what will you do? Step 1, what will you do? N equal to 1, is it right? So put n equal to 1. Substitute here n equal to 1. So 1 square plus 1. It's equal to 2. Whether 2 is an even number or an odd number? Even number. So what will you say? What will you say? P of 1 is true. Next, what will you do? In step 2, what will you assume? P of k, is it right? So let us assume that P of k is true. Okay. Therefore, in the place of n, what do you need to put? K. So k square plus k is an even number is true. Okay, in the last problem I said this, is it right? So here it's divisible by 7 means 7 into m, is it right? So even number means it is in the form of 2 into something. So 2 into m. So 2 into 1 is the first even number. So 2 into 1, 2 into 2, 2 into 3, 2 into 4. Whatever is the multiple of 2, it will be an even number. So this we will take as k square plus k is equal to 2 into something. We will assume this is equation number 1. Okay. Now in step 3, what will you prove? To prove P of k plus 1 is true. P of k plus 1 is true. Okay. So in the place of k, what do you need to substitute? K plus 1. So k plus 1 the whole square plus k plus 1 is an even number you need to prove. So that's equal to, simplify a plus b the whole square. A square plus 2ab, is it right? A plus b the whole square means a square plus 2ab plus b square. So k plus 1 the whole square means k square plus 2k plus 1 plus k plus 1. That's equal to k square plus k plus 2k plus 2. Okay. That's equal to, in the place of k square plus k, using 1, what you can write? 2m, is it right? So 2m plus 2 into k plus 2. So that's that's equal to, what is a common here? 2 is common. So m plus k plus 1. Whether it's the multiple of 2 is a multiple of 2. So whether it's an even number? Yes. Is it right? So therefore k plus 1 the whole square plus k plus 1 is a even number. Okay. Is a even number. Therefore we will say P of k plus 1 is true whenever P of k is true. So if P of k plus 1 is true, whenever P of k is true. Therefore P of n is true for all n belongs to n. This is a symbol for all. Okay. So here this one, k plus 1 the whole square in the place of k plus 1. Okay, so you got the multiples 2. If it is even number, 2, is it right? So 5 means 5 into something. So same as previous problem. Understand, students? So 5 examples problems are there in this exercise. So this one we have completed. So let's move to the exercise problem. In exercise, 9 problems are there. So first problem I gave homework for you. I hope you all completed. Now it's the time to give the homework. Afterwards, remaining we will continue. Okay. So all of you take down your books. Note down the homeworks first. Take down your book. Exercise 2.5. Homework is problem number 5, problem number 7. Problem number 5 and 7. Okay. Now today we have completed, is it right? These are multiple of 7. One problem we did know. So that same model, problem number 5 and 7. So here in 5th problem, 3 power 2n minus 1 is a multiple of, divisible of 8 you need to prove. Okay. In 7th problem, 5 power 2n minus 1 is a divisible by 24 you need to prove. Okay. So everything same model. So now in the class we have completed divisible by 7. So 7 into something. So even number means 2 into something. What right I said, is it right? So same as here, 8 into something, 24 into something, like that you will get. So 5 and 7 is the homework. Understand? So remaining 6 problems are there. That one we will do in the class. Understand, students? Okay. So first problem, I hope you all completed. Now let's move to problem number 2 in this exercise. Okay. Exercise 2.5. Problem number 2. By the principle of mathematical induction, 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus n into n plus 1 is equal to n into n plus 1 n plus 2 divided by 3 for all n belongs to n. By the principle of mathematical induction, 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus n into n plus 1 is equal to n into n plus 1 into n plus 2 by 3 for all n belongs to n. Okay. So first what will you do? P of n, is it right? So let's P of n denote the statement. Denote the statement. What's the statement? 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus n into n plus 1 is equal to n into n plus 1 n plus 2 divided by 3. Okay. So what's the step 1 we will do in step 1? What's the step 1? N equal to 1, is it right? So put n equal to 1. Here LHS and RHS is there. So we need to put for LHS and RHS, is it right? So n into n plus 1. So n means 1. So 1 into 1 plus 1. So what's the value you will get? So same value you need to get there. Okay. LHS. What's LHS? N into n plus 1 is LHS. So that's equal to 1 into 1 plus 1. So 1 into 2 means you will get is 2. Okay. So RHS. What's RHS? N into n plus 1 into n plus 2 divided by 3. That's equal to 1 into 1 plus 1, 1 plus 2 divided by 3. So this and this 3 will get cancelled. So 1 into 2 is 2. Whether both are equal? Yes. So LHS is equal to RHS. So what will you conclude? P of 1 is true. Okay. Next what will you do? We will do for step 2. What's the step 2? Let us assume P of K is true. Okay. P of K. of n, you need to substitute this k. So 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus k into k plus 1 is equal to k into k plus 1 into k plus 2 divided by 3. Okay. So take this as equation number 1 for substituting. Okay. That's step 3. Okay. So third step, what will you do to prove P of k plus 1 is true? Okay. So in the place of k, you need to substitute this k plus 1. Okay. So you want to be very careful here. 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus this is I said this is right when we are doing the problem. This is a previous. Next means k plus 1. So k plus 1 into k plus 1 plus 1. So k plus 2. Got it? So here also is substitute. Okay. So in the RHS when you are substituting, what will happen? K plus 1. So k plus 1 plus 1 means k plus 2. Here k plus 1 plus 1 means k plus 3. Is it right? K plus 3 divided by 3. Okay. So this one is a thing. So now you take the LHS. Now take down the LHS here. What's the LHS? 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus k into k plus 1 plus k plus 1 k plus 2. Okay. So using 1 from here to here, you can substitute one value. So you are using 1 from here to here. What's the value will substitute? So k into k plus 1 into k plus 2 divided by 3 plus k plus 1 into k plus 2. Okay. Now take down the common outside. So k plus 1 into k plus 2 is the common. So what's the balance? K by 3 plus 1. Okay. That's equal to common took outside. So k plus 1 into k plus 2. Here 3 LCM. So k plus 3. Got it? So what's the multiply inside? K plus 1 into k plus 2 into k plus 3 divided by 3. Whether RHS? Yes. Yes or no? Yes. Therefore, we will say P of k plus 1 is true for all. True whenever P of k is true. Therefore, P of n is true for all n belongs to n. Understand? So these are the problems you can do as homework, but this section is very important. Because of that I am doing everything. So do it correctly. Okay. Let's move to the next question. Problem number 3. 4 plus 8 plus 12 plus etc. plus 4n equal to 2 into n plus 1 for all n belongs to n. Solution. First, what will we do? Assume the statement is P of n. That is, let P of n denote the statement. What's the statement? Write down the question. 4 plus 8 plus 12 plus etc. plus 4n equal to 2n into n plus 1. Okay. Next, what did we do for the first step? Step 1, what did we do? Put n equal to 1. Is it right? Substitute n equal to 1 in the RHS. That is 4n. Is it right? This is LHS. So 4n. So 4 into 1. That's equal to 4. Now come to RHS. What's RHS? 2n into n plus 1. Substitute here 2 into 1 into 1 plus 1. So that's equal to 4. Whether both are equal, LHS is equal to RHS. So what will you say? P of 1 is true. Next, what will you do? Step 2, what will you do? Let us assume, what you will assume? Assume that P of k is true. Let us assume that P of k is true. So now assume 4 plus 8 plus 12 plus etc. plus 4 into, in the place of n is k. So 4k into 2k into k plus 1. Take it as equation number 1. For substituting, it will be very easy for you. Okay. Now come to step 3. What is step 3? To prove P of k plus 1 is true. To prove P of k plus 1 is true. So 4 plus 8 plus 12 plus etc. plus 4k. Next, what will you get? 4 into k plus 1. Is it right? Okay. That's equal to, RHS also substituted. 4 2 into k plus 1 into k plus 2. So let us take the LHS first. From here to here, what's the value? We can substitute by using 2k into k plus 1 plus 4 into k plus 1. Now that's equal to, simplify. So 2k into k plus 1 plus 4 into k plus 1. Is it right? So if you are simplifying, you will get this. How much you will get? Shall we take k plus 1 outside? So what will is the balance? 2k plus 4. Is it right? So that's equal to k plus 1 into 2k plus 4. Is it right? So next, what will you do? Shall we take from 2 here outside? So 2 into k plus 1 into k plus 2. Whether both RHS are equal to RHS. Is it right? So what will you say? P of k plus 1 is true whenever P of k is true. Okay, so P of k plus 1 is true whenever P of k is true. Therefore, P of n is true for all n belongs to n. Got it? Very easy, very important also. Okay, so learn it. Understand? So in example problems, in LHS, RHS, I directly did this, it right? So that method you are following means also no problem. Okay, so equal. Got it? Okay, I hope you got good idea. So I think 4 or 5 problems are left in this exercise. So we'll continue the same in the next class. 2 problems I gave homework for you. Problem number 5 and 7. Please complete it, student. We will meet in the next class. Maintain your class work neatly. Learn every day portion. Thank you, students.